Okay, Kellen and Aubrey, this is section 5.3.
Of course you do.
And here's the homework. Ugh, kind of a mess. Page 309, we got number 2, number 4, number 5, number 8, number 10, number 17 through 20 all. Okay, because those are kind of like a yes-no thing. Okay, so not terribly many homework problems, but problem. 2, 4, 5 are proofs. Oh, boy.
Oh, shit.
Oh, boy. Okay, now, we're learning new types of proofs. There are 2 types of proofs that we're going to do today. Or in this lesson, which we may not get in today. This might take 2 days, right? So SSS and SAS. You don't know what they stand for, but you're going to learn them here in a second. No, that is not a thing. We'll talk about ASS, actually. We do. Okay?
Definitely is a thing.
Because that is not a thing. Okay, now, we're going to talk about it. Now, these 2 we're talking about today, in the next section, which we probably won't start until Monday, because this will probably take 2 days, we're doing 2 other ones, which are, no, not ASS. AAS and ASA.
Ken Carson's SS.
AAS and ASA. Is that I said that right? Yes. AAS. No, wrong. Anyway, okay, so these next 2 sections are similar. They kind of go together. You're learning a common theme, whatever. But we're doing proofs, and in order to be able to do proofs, we have to have some stuff in our toolbox to be able to prove other things. So, things that we're going to put in our toolbox. Here we go. The
Drill.
stuff from the previous sections. This is from section 5.1. This is from section 5.2. I don't know what the number is, but the name is the exterior angle theorem. He's important, and we're going to write him down. The other one is the third angle theorem. Okay? Oh, I abbreviated theorem on the second one. Okay, write this down. You're going to want to have these, okay? Because you get to use this paper on your test. And you want to have these tools in your toolbox to have them on the test. What? No. Do a good job. Do a good job. Okay? And this is Jace's paper, so thanks, Jace.
You're welcome.
Okay. All right. Example.
That's explanation.
I'm gonna write the picture or whatever. Okay. So draw the picture first. Draw the picture first. 1, 2, 3, 4.
How many?
Those are the names of the angles, by the way. 1, 2, 3, 4. Okay. All right. In my explanation, this is the third angle theorem. So we're talking about, or not the third angle theorem. This is the exterior angle theorem. Which angle is the exterior angle?
4.
Angle 4. Okay. Angle 4. So if we're talking about measures of angles, angle 4 will be the same as the 2 sides he doesn't touch added together. 2 angles he doesn't touch added together. Which 2 angles does he not touch? 1 and 3. So I can say angle 1 plus angle 3 is equal to angle 4. Hey, that's kind of handy because 1 and 3 equals 4. Ha! I didn't do that on purpose, but anyway. 1 plus 3 equals 4. 2, we don't even have to figure out what 2 is, right? We don't even have to figure out what 2 is, but that's what the explanation is. So, now that we know that, we get to take shortcuts, right? Okay? All right, the next one is something called the third angles theorem. So, let's do this. I'm going to put them like this. I don't know. Like 2 bird beaks touching. I don't know. Anyway, this one. This one.
The birds are kissing.
This one. This one. Okay? We'll call this A, B, C, D, E, F. I don't know. Okay, draw the name picture. Quit worrying about what he's called. A, B, C, D, E, F.
They're touching things.
Wow, we are sophomores and juniors in here.
Yep.
Whatever. Okay, we have 2 triangles, yes? We have 2 triangles. All right, if angle A is congruent to angle which one? D. How do I know that? Because it's marked. And, let me do not a comma, and angle B is congruent to angle E. Those are things that I know because of the diagram and because of how he's marked. Okay? They don't have C and F marked that they are the same as each other, right?
But they are.
But are they the same as each other? Then, by default, angle C has to be the same as angle F because they're the third angles, right? If these two match those two, then C and F are the same.
Yeah.
Not like default, like Brady at Fortnite.
Okay, good? Yes? Wonderful. All right. 3 more things. Ready?
Chicken fries.
I'm going to split this in half because he's not a very important thing. So I'm going to do this.
No, I didn't. Yes, you did. I was making it longer.
Oh my
I'm gonna
god.
use every single one.
Okay. This one is going to be called the symmetric property. This one's going to be called the transitive property.
We already had that one,
Yeah.
but I don't know my boots.
And this is called the reflexive property.
I need to.
Okay, put the reflexive property on the big one because I'm going to draw a picture for him. Okay?
Are we gonna run out of squares?
No.
There's a
Why are we? So
backslash.
why?
Those
are
are,
we-
I mean, you could, well, because you don't need that much writing.
I know what a puff is.
Oh, it's gonna be the same
Okay, fine.
amount of writing, just not
Fine.
space.
I make them little tiny guys because, like, they're just properties. They're not, like, big old theorems. So if I'm looking for them on my sheet, I know that I'm looking for, like, smaller. I don't know. Whatever. You just do what you do. You do whatever you want to do. I don't care. All right, symmetric. Symmetry means flipped over an axis, right? Symmetry. So here's what I know. I know that if angle A, I'll say if, right? If angle A is congruent to angle B, then, there's no picture with this, then angle B is congruent to angle A.
Well, that makes
That's the
sense, don't
symmetric property. Okay?
Add that to the back.
This is like, you know when you solve an algebra problem and you end up with 2 equals x and you're like, oh crap, I don't like it written like that, so you write it as x equals 2. The symmetric property is what allows you to do that because it's symmetric. It's the same on both sides, right? So you flip it around. Okay? That's the symmetric property. Kind of a dum-dum. That's why I made him a little guy, right? Okay, the transitive property is this. If angle A is congruent to angle B, and angle B is congruent to angle C,
Scoop your eyeballs
then,
out with a spoon tonight,
shh,
boys.
be quiet. If angle A is congruent to angle B and angle B is congruent to angle C, then we skip over
A is equal to
Owen.
C. Jack told me to say that.
Then we skip over Owen, right?
I forgot about someone else over there.
I don't remember who the other 2 people were. I only remember Owen, right? I think it was Wyatt and Trevin. So if Trevin is younger than Owen and Owen is younger than Wyatt, then Trevin is younger than Wyatt because we skip over Owen, right? Okay, so that's the transitive property, also called the law
Of syllogism.
of syllogism. That's the law of syllogism, the transitive property. Okay, all right. Are you ready? This one is going to have a picture. Shh, listen. This one's going to have a picture. Okay. And this one is saying that, you got to listen.
I'm not. You are.
Okay, here's this one. This one deserves some explanation because you're like, well, duh, right? AB is congruent to AB. Well, duh, it is, right? There you go. Write that one down. AB is congruent to AB. Like, that seems like dumb.
It is dumb.
Reflex.
Okay, here we go. This is what we're going to try to do. This is the reflexive property. Remember, reflexive property, AB equals AB, or congruent to AB, okay? Here's how this works. Ready? Draw this picture. Whoop. Be quiet. Shh. Okay, here is this. Yeah.
Yeah.
Here is this. Okay? All right, in this section, we're going to be trying to prove that 2 triangles are congruent, right? Same shape, same size, okay? So, in this diagram, I'm talking about this triangle right here. I want to prove that he's the same shape, same size as this triangle right here. So, I start to split him into parts, and I start to look at his sides and say, like, this side is the same as this side, right? So, maybe this side is the same as that one, right? And maybe this side is the same as that one. I don't know, right? Okay? But in my proof, when I make my statements to say that those sides are the same as those sides, one of my steps is going to be that AB is congruent to AB. Now the AB, the first AB that I'm talking about is for triangle 1, which is this guy over here. I'm talking about AB for this triangle. That side is congruent to AB for the second triangle, right? So they're the same side, but they're talking about two different triangles, right? AB is congruent to AB, yeah?
Yeah.
Okay, so this is a point when we use the reflexive property. You will use him quite a bit on your homework assignment, actually, a lot, okay?
Touch me again, chubby boy.
Anytime, listen, shh,
You got me there.
listen, anytime you have two triangles that are butt up against each other that are sharing a side, you're probably going to use the reflexive property at some point. Just know that, okay? So on your homework assignment, if you're looking at the two things, you're going to use the reflexive property at some point if those triangles are touching and sharing a side. Got it? Okay? All right. There you go. Those are the things we're going to write down. We're probably going to maybe add to this here in just a minute, but let's go do some homework. Or let's go do a problem. Okay? All right. Yeah, we are going to add to this. Okay. So, first thing. Shh, listen. Listen. All right, this is my first diagram on example 1. Is this example 1? Yeah, example 1 right here. Ready? Listen. This is the hardest part that you guys will probably do in math, in like geometry. So you better listen. Okay, this is what geometry is notorious for people hating, right? It's proofs. So make sure you're listening. Okay? All right. Okay, here's what we're trying to do. This diagram right here has two triangles in it, the left and the right side, yeah? So, be quiet. Shush. Turn around. Shh.
Hell, I did.
I think they look like the same triangle.
1 and 2. Our goal is to try to show that those two triangles are congruent, which means the same
They're about the
Shape and size.
shape and size. Same shape, same size. All right. So I have to prove that, but I have to be given some information. You turn around and be quiet, or you're going to get shipped off. I'm serious. Okay, I'm done. Like to the office, and he can sit there for 2 hours. I don't care. Okay. Left side, right side. You
put me off.
sit.
Ouch.
I have a broken chair back there for that reason. Okay, 1 and 2. Those two triangles are congruent. We're going to try to prove that. Now, yesterday, the way that we had to go about talking about these triangles being congruent is talking about all the parts, okay? So we had to list out, don't write this down. We had to list out all the angles, and we had to list out all the sides. And if we're doing triangles, we have 3 of each, right? So we would go through and we would say angle Q is the same as angle S, and angle R is the same as angle R, and angle T is the same as angle T. Do you remember that being a pain in the butt? Yes? Okay, and then I start with the sides, and I say like QR is the same as SR, and I go down and I go through all the sides. All together, that is how many parts? 6 parts, right? 3 sides, 3 angles. Be quiet. 3 sides, 3 angles. 6 parts total. Here we go. We're going to go from 6 down to 3. Okay, here's how this works. We're going to go down from 6 down to 3, and the 3 are these. SSS is the first one. Okay, you got to listen. SSS is the first one. SSS stands for side, side, side. So here's what happens. They say, based on SSS, you don't have to write this down. Based on SSS, if I know that this side matches this side, and this side matches this side, and this side matches this side, I don't even have to talk about the angles, because no matter what, by default, the angles here have to be the same as the angles there. I don't know how to talk about the angles, right? I get to go from proving 6 things now to only talking about 3 things. That makes it easier, right? So when I'm doing a proof, all I have to do in the proof is look for, have I shown that these 2 sides match? Have I shown that these 2 sides match? Have I shown that these 2 sides match? If I did that, then we're good. Then we're done. Okay? Yes? So that is side, side, side congruence. We don't have to talk about the angles. Yes? All right, so let's go to this. When they say write a flow proof, we will not write any flow proof. So on your homework assignment, you're going to change that, and it's going to say a 2-column proof. A 2-column proof. So proof. Switch those to say 2-column proof. Got it? Switch that to say 2-column proof. All right. Now I'm going to make you really mad. Whoop. Hold on. Because you're like, I can't do that on mine. Right?
Can't do that on mine.
Ah.
Good one.
Okay. All right. So put it over here in the corner or something. I don't know. Here's what your 2-column proof looks like. So put your 2-column proof, I don't know, somewhere else. Like over here in the margins, because you didn't write here. Okay? All right. Here we go. 2-column proof. Every 2-column proof is going to start with 2 columns like this. You're going to make a chart, and the left side is going to be called statements. And do you remember the right side?
Nope.
Reasons.
Yeah.
So I'm going to list out things, and I'm going to say why I'm able to say that. Okay? All right. And then what I've started doing is when we do these, I'm going to have a little spot over on the left side for me to take inventory as I go through this proof. Okay? We're going to take inventory.
So we don't have to do any flow proofs?
No flow proofs. Everything's going to be
Okay.
2-column style. It's going to be easy. Okay? All right, here we go. We have this going on here, all right? We have that triangle QRS is isosceles, okay? QRS is the overall big guy, right? Okay, that whole big triangle. That's isosceles. What does that mean? 2 sides are the same, and they tell me which 2 sides are the same. They say this right here. Circle that. That's important. QR is congruent to SR, okay? That's the first a really important piece of information they give me, and I'm going to mark it on my diagram, okay? How can I show that QR is the same thing as SR? Yeah, let's do a little tick mark. Okay, do that on your diagram. Circle this piece of information, do your little tick. Okay? Circle that information, do your little tick. Okay? Now, I'm not going to read, listen, I'm not going to read the rest of the given yet. I'm going to write down the information that it gives me, okay? So, QR is congruent to SR. I'm going to write that down. How do I know that I'm able to say that? Because it's given to me, right? Okay, that's an important piece of information. That gives me something, right? In my diagram, that tells me if I'm taking inventory that I have a side that's matching another side. So over here in my inventory, I'm going to label that as a side. I have a side that's matching. You one more, and you're done. One more, and you're done.
What did I do?
Okay, I have a side that's matching. Now, I'm going to do the next piece. Okay, the next piece says that RT bisects QS at point T. RT, this guy, is cutting QS in half. It's bisecting. What does that mean? Right in the middle. So that tells me if it's right in the middle that this guy is the same as that guy, right? Okay? So I have to write this down. I have to write that RT bisects QS. Okay? Well, how do I know that? Because it's given. Okay? Now, that doesn't right now give me another side because I have to write that side down, right? So if RT is bisecting QS, I know that QT will be the same as what? TS, I'm going to go ST, right? QT is the same as ST. Got it? Now, how do I know that?
Because the one law that
Because it's
symmetry.
like a bisector. I'm going to say definition of bisector. By definition, what it means to be a bisector. If it's bisecting, then those two things are the same, right?
Symmetry?
What? No. Because just because it's symmetric, but it doesn't say anything about symmetry. It only says it's a bisector. So by definition of what it means to be a bisector, it's splitting into 2 equal pieces, and I have that. All right. In my inventory, I now have 2 sides. What do I need left?
Third side.
I need a third side. Okay. So which side am I missing? I'm missing this third side. 1, 2, 3.
Reflexive property.
TR is congruent to TR by the reflexive property.
And that's it?
Okay? That's my third side in my inventory. So finally, I'm able to say that triangle QRT is congruent to triangle SRT.
So number 2.
Now, hold on. What's my reason for saying that final? By SSS congruence. I'm just going to say SSS, right? Because of side, I don't have to prove the angles now. I only have to do the 3 sides, and those 2 triangles are congruent.
What is SAS again? You're in SS.
SAS will be side, angle side. So we'll get to that. Okay, do you see how that works? Yeah? Not too bad?
Comments are snowing.
Okay.
I said, tell me that
I
already.
said, what was that?
All right. Let's have you do.
What did you have?
We're done. We're done with notes for today because I don't want to snow you anymore. Let's have you do. Let's have you do 2, 4, and 5. Try 2, 4, and 5. Now, when they say flow proof or paragraph proof, you're just going to write 2-column proof. So start each one with statements, reasons. Start each one with statements, reasons.
Are they all
Start each one with statements,
Are
reasons.
they all gonna be? Are they all gonna be SSS?
Number 2.
They're all going to be SSS. These are all SSS. Okay?
He forgot to teach us part of our trig lesson today.
Ah,
I don't.
okay, happy with that? Try your best to do this. Write down your inventory. If you don't know where to start, where do you start? With the given, right? That's the beginning. Start with the given. Okay? All right, write down your given and then write down what you need. Write down your given, take inventory, then figure out what you're missing,
I
right?
need to take inventory.
All right, there you go. Okay, goodbye.
Can you go back to that one example?